What
The
is started?
stirrer, the stirrer in this case.
Now when does it end?
After 25 seconds. The outlet is triggered. And the fourth one, sir, would be the outlet.
Outlet. Now when does it end?
When the lower level switch is triggered, that's LLS.
What we forgot to put is that the buzzer is supposed to trigger that time too. If we're reading the thing correctly, let me see.
Yes, sir. Yes, sir. And I think it's supposed to last
When the
for
mixing
5
process is
seconds.
completed, the buzzer will be activated. So this is the outlet. All right. So now all right, so I'm going to repeat this from step 1 10 times. So the last thing that we said now was that we use this to write up our program. Um, I don't know what is going on with these things, like that. All of them are malfunction. Give me a second here. The mouse is giving me a problem. right, so write the program. So the first line starts when the start button is pushed. So all right, so the start button we had a 00. We have now a 0. As 000.00, and it is LSA. The LSA was 00002, and inlet valve, inlet 1 was 1. All right. I'm going to try to do something. Try to, because the mouse and everything is giving pure problems. All right. So the next one. Next line. 02, and it was the inlet 2. And what stops it was LSB. Next line was timer stops it. So we put timer 1. And the stir is 03. Next one, the timer 1. What is happening is that there's a delay. So I can see the things as alright. 004. And it's a level switch. The level switch, which was 000.04. At the timer 1 that starts it. And I'm putting it in like this. Timer 2. What is the buzzer? Then I have inlet switch, outlet, So that is the program that we have. Now, what we want now is two things that we have to add to this program. We have to add to the program that we want it to loop. So we want the program to start over. So how do we get the program to start over?
Just a point, sir.
Well,
Sir,
I didn't hear
Just-
it. Mhm.
just making a point. Last class you had two boxes for the time program in the code as well. That's T1 and T2.
Oh, forget the timer. All right, well, wait to get to the timers in a little bit. I'm going to get to the timers in a little bit. I'm leaving them out for the time being because there are some things that I have to write about. So let me leave them out for a little bit. I shouldn't have, but let me just leave them for it. I need to illustrate a point. All right, so we have to start back over the program. So we have to go back through and start back over the program. So we are at the end. So we are done here. And we need to go back up and start back over. So this is simple to do. Looping is simple to do in when we're talking about our PSC program, because the simple way to do it is to what we need to start back over the program. This is the final thing that stops the program, stops level switch 2. So we need to look at the end of the program. What's the final thing that stops it? And we use that to start back over the program. So what we do when we are looping is that we put that switch as an OR. So 000.04. So what we are saying is that either the start switch, this is my start switch, or 04, which is a lower level switch, can start the program. So when I put it as an R, then it can start the program. So that's fine. So, but what we have now created is an indefinite loop. It's better we continue. So when it reach here, this trigger stop these two, it's going to also trigger at the top of the program to start back over from 100. So it would continue forever, but we don't want it to continue forever. We want it to continue. Want it to do 10 times and then stop. So the first thing that we want to make the point is that when you're looping, whatever ends the last line, the last structural line of your program is a line which you use to begin the program. So look at what stopped the last line of your program. Well, not the timers on those things. Although there will be lines in your program, but is the last working line of your statement list that you'll be using. So now, you want to count 10. So what you need is a counter. So I think a counter CNT, and I'm going to call it counter 1. Sorry, not counter 1. Cannot call it counter 1. That's the first thing. Counter, the code is CNT. But when you write it in the program, just like for the timer, which you have T1, it is going to be TIM1, counter is CNT. And we have 2 timers already in the circuit, timer 1 and timer 2. Counter, we have to put counter 3. So, and it's very important. The program doesn't distinguish between timers and counters. So if you put timer 1 and counter 1 in the program, you have a timer 1 and a counter 1, the program is going to see it as two same things operating very differently. Be confused and just sit down and look at you. It will indicate that there's an error in the program. It's just going to not function. And so whenever you have a program and everything they say everything is fine, you need to look and see what is the problem. If you have labeled, the first thing you need to look and see if you have labeled all your timers and counters properly. They must be separate. All right. So, because to make a politically incorrect joke, just let me tell you, so the timers and the counters in the program is going to behave just like some of our wife. What is the problem? Nothing. But so there must be a problem. No. So that is what it's going to behave. But you can't see the problem. You need to go and check the timers and the counters. So it has to be timer 1, timer 2, counter 3, timer 4, counter 5, and so forth. Now, last week, we said we want the counter to count 10. So we can put number sign 10. It's not like the timer now. The timer, the 2 timers that we had in the program, I'm going to put them here. So we had timer 1. And it was, we put, for 25, we had to put 250 because the timer counts in default of 1 second. And for timer 2, it's supposed to count for 5 seconds. So put number sign 50. And what's supposed to trigger timer 1 is where we're saying we'll use the output I feel I should log out and log back in. 100.02 and the timer 2 now. Well, we can look and see the line that it is in, so we can use timer 1 to start timer 2. All right, so timer 1 and timer 2, and so we say counter 3, 10 seconds. But if you notice the other thing, I have 2 inputs to my counter, only 1 input to my timer. The timer start, when you finish count timing, it stops. But counter, when you finish counting, you have to reset it. So you have to start for the counter and you reset for your counter. So the counter, what do you want the counter to count? You want it to count the amount of times it has gone through the cycle. So you have a variety of things that you can use to count, but all of them in this particular case And in most cases, all of the things that you're going to use to trigger the counter to say that we have finished a batch is in the last line. So any one of these inputs in the last line, timer 1, 0, 0, 4, that's a lower level switch, the outlet valve or the buzzer, you can use to indicate to the counter. So all right, every time one of these go off, one of the things in the last line, every time anything in the last line goes off, then you can use them to indicate that you have finished a batch. So I am going to use the buzzer. It's an arbitrary choice. So every time the buzzer goes off, we're going to indicate that a batch is done. What do we use to reset the counter? So I'm using all of the default things this evening. Of course, there are going to be programs that are going to be different, that they're going to need you to think about the problem a little bit more and think about the problem a little bit differently, but I am using all of the go-to. The first thing you think about, and then you say, no, not that, that's not going to work. So whenever we are counting anything and we want to reset the counter, the first thing that we think about, the first thing that we should think about to use to reset the counter is when I start the system I come into the plant and I'm pressing start to start the system. So you use that to reset the counter because that's where you know you're starting from 0. All right, so when everything is off, I just pressing start. So the first go-to thing that you think about, and then you look at see will it work. All right, so our start switch was 0, 0, 0. That's 0, 0. So your start switch, you see if it resets the counter. If it does, if you think about it, if I press this start up here, if I press the start up here for the start of the program, and I reset the counter at that point in time, when I reset the counter, it starts from 0, then it is ready to start for the batch. So that's your go-to thing. I cannot tell you anything else other than if you have to think about what you can use to reset the program, the counter, if you have a program that you want to run. All right. So, and we had said that you would put in end. Not that this is necessary, just good programming practice. We're not finished because yes, the counter is going to count 10 and the looping is going to loop and loop and loop. But the counter only purpose is to count. It's not to stop anything. It sends a bit high, yes. So we have to stop the program. So here's what we do. I'm going to first line, and I'm going to give myself a bit of space. In the first line of the program, we put C1 as well as 0, 0, 0, 2. So now that is 100. C1, C3. Mr. making the same mistake I tell you the wrong make. C3. So you put the counter in the first line. So when the counter finish 10, it's going to stop the program. So everything supposed to stop. Some people put the counter in every line, but it is not necessary. All right. One other thing now that I need to deal with, because I conveniently ignored it last week. I think nobody did. I don't remember if anybody did ask me a question about it. But we have a stop switch. And the stop switch is not part of the automatic system. But suppose somebody falls into the tank. You need to stop everything. So now the stop switch, one way of doing it, not the only way, but one way of doing it is to put it in every row. So this is my stop switch 00002.
Excuse me, sir. What is the other 00002 in the line?
Oh, what is the stop switch again? It's 00001, no?
Oh, okay.
Yeah, stop is sorry. 0001. Forgive me this evening, like I said, we're not feeling so well, and then this thing here apparently feeling the same way like me, because it does everything 3 seconds after. Draw it right 3 seconds after or longer as it as I'm going to put the switch here for convenience, but it really should be over the other side. Granted, sir, we don't care if the buzzer sounds when we need it. All right, so this will be our complete program. It kind of messy, but it's because we're having some problems with the writing implement. So forgive the messy look. All right. So in conclusion, when you want to loop, you create an indefinite loop by using the last trigger for the system to start work over. And you can use, I could have used T1, 10003, 10004, 0004. I could have used any one of these to start back over my program. But usually you go to whatever stops the last thing is what starts back over the program. So the start is either 000 or 0004, the lower level switch. Of course, I'm sitting here and I'm saying to myself, so that can be a problem. Using the lower level switch can be a problem. If I'm using normally open switch. If I'm using a normally open switch, then if it is a normally open level switch, a level switch is like the ball in your toilet tank, and it when the thing is finished, it is you have it and it is open, then well, we wait until we start right up before we discuss all of those things because it's the imagination we have to appeal to right now, and that doesn't make no sense. So we leave that for the time being. So lower level switch we use it. But I'm just saying you have other options. So if you see that won't work in your program, then you use T1 or 1003, which is the valve, or 10004. Whatever is giving problems in the program, just like what we tell you, so when we wire it up, everything simulate and work properly, but when we wire it up, the level switch didn't work, so we had to use the output to trigger the timer one. All right, so that is your program. Like I said, it kind of messy, so I don't know if you understood what I was trying to get at. But there's two things: loop and count. That is what I wanted to make mention of. So any questions there?
Yes, sir. I get what you're saying about just a question, some stuff. For the reset on the counter, why is it that you could have used a stop to reset it? Why use a start?
All right. So you could use a stop. It's not that. That's what I'm saying. That the what you use for your reset is not something that you is one only. I was just saying the go-to is the start. What the counter does, it goes 1, 2, 3, and then it goes straight down, in this case, to 10. And when it's 10, when you run in the program, you see it reach 10 and stop and stay at it just reach 10. Sorry, it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, trigger. And stays there. So it count 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And it stay when you will see it stay at the final value and not move. So what we say now is that to get the counter to go back up and say 10, when you press something in the program to say 10 to be ready to count again, then what I was saying is that the start switch is a good, because when you start in the program to run the thing, the start switch, if I press the start switch, then it's going to cause the counter to go back to 10. So, and that is at the beginning of the program. Just when you start in the program. So it is always the go-to thing. So when I start, I want to clear everything. Because like when you write in our C program, one of them things they have our microprocessor program is you clear all of well, this is a microprocessor program. So you clear all of your registers at the start of the program. That's the first thing you do, clear everything. So that's why I say start. But stop, if I press stop and it registers, it clears it. As it would in this case. Then there's no issue with using it. You can use the stop switch. Huh?
I think the start would be more efficient because you don't want to reset it as you start the program.
As you start the program. But if you reset it as you start the program, it's still not an issue. But bear in mind the following, that you have to think about the people who operate in the system. So it's supposed to operate and run 10. And when it operates and run the 10, it's going to stop. See the counter going to stop it. It's going to stop, and somebody going to say, I have to run another batch and press start again. In other words, the person would have to physically remember, say, oh, I have to press stop, Because remember, says the program as we have it here now is not the stop switch that stops it. The stop switch is just an emergency switch as we have put it inside there. So if any emergency happens, then we stop the program.
Exactly.
but the stop switch is not automatic. And if when you work with people, you know, well, maybe because we have teenage boy in the house who not see nothing to do at any time. And where it is wheelbarrow type of people, where you push them, when you push them, I left them at the sudden state. Until you're so anyway, let me not do regarding my personal business.
Sir,
So,
we have our next
what I'm
question
saying is that the human factor, see. So I don't know if I answered the question.
Yeah, man, you
Why-
answered clearly, sir.
I wouldn't necessarily. All right, I wouldn't necessarily use stop, but stop can work. But the person would have to remember, say, I have to press stop before we start over the thing.
That's why I said it's
And not everybody will. It's not. It's more efficient because when they have to press start to start the thing, so start clear up everything immediately.
Yes, sir. The
All right,
other
but this,
question.
using that is not unique.
You hear me, sir?
Mhm.
You see where you have the
Yeah,
counter
I'm here.
at the top line. You said that you don't need to put the counter in every line because it will automatically stop it. I can just run through why would I stop it since that some of these have latches. Well, all of these are latched. Is it like how you put the stop on everything? What would cause the counter to stop having the other lines?
All right. So now, the stop is in every line because it's a safety device. So somebody drop in the mixing tank and you want to stop it, and let us say that you're at this point in the program because the program is running sequentially. Let me digress. Ladder logic programs don't necessarily. We have written it sequentially. That is why it is running sequentially. Any line that you trigger, that is what works. But we have written it so it runs from line 1 to line 2 to line 3 to line 4. So I am saying now that is when the inlet valve 2 turn on, that something happen. And let us use the theory. Say somebody jump in at the tank or somebody drop in at the tank. So yeah, but say shut it off before the mixer start. So when you turn it off, it will turn off every line. Now, if you put C3, if C3 now is at the beginning of the program, when it reached 10, you put C3 there and it shuts off 100. So it's going to shut off this. Remember, so now you're at the beginning, tank starting to fill up. Or the tank's supposed to start to fill up, but at reach the end, it can shut off 3. So therefore, the first line is not going to run. So if the first line doesn't run, then the second line won't run. And if the second line don't run, the third line don't run, and so forth and so on. So that's why we could just put it in one line and leave it. Some people put it in every line, but we can't just put it in the one line and leave it because it is a loop. And if the first line don't run, the second and the third and the fourth won't run. The stop switch is put in every line because you don't know which line you will be whenever the emergency occurs that you want to stop the thing. Because if you just put the stop switch in the first line alone, it will have to complete the cycle before it will complete the cycle before it will go through from 2 to 3 to 4 before it go back up to 1 and say, okay, the stop switch is triggered, so I will stop. You get what I'm saying? So I can put C3 in the first line because when it go through the cycle, I want it to stop at the first line. But I put the stop switch in every line because no matter where in the cycle it is, I want it to, I would want everything to stop. I don't know if I answered the question. So you understand?
Yes, sir. Yes, sir. One last thing now.
Yeah.
Why is it that we need 2 separate start and stop? I think I did answer that already, but Because the start is because of some automation where you need two separate
because-
start and stop.
Because most automation systems have that is the get out of jail card. But let me say most panels come with a start and a separate start and a stop. You don't have the single pole single throw switch that you're going to use one mean start and one mean stop. For your equipment, it is better to have a separate start and a stop switch, so that because if you look at the program that we have here, if the start switch was boy, I was trying to draw something and then, like I said, there's a delay. So if you start was one position mean on and one position mean off, then there'll be no need for this latch. There will be no need for the latch, and then there would be no. I tried to find the best way to put it. You need two different set of control. Basically, think about it that way. You need your stop to be independent of your start. You don't need them to be married. You need them to be separate. To do them own, be able to do them own thing in their own way, not tied to each other.
Safety reasons.
Yeah. All right. So I don't know if we answered that question properly, but forgive my discombobulated state at this present moment in time. All right. So any other questions? If no other question, then I just want to make mention of one last thing and then stop for this evening because I feel like I'm going to catch fever. Yeah, and everybody will say, everybody jump and say, COVID.
Close to the ground.
Huh? Because our feelings, everybody in Jamaica catch whatever from Bridget at hospital. The one Dr. Bridget, almost everybody who come inside, if they have liquor flu or COVID, they have. I tried to. All right, I'll get to log out and because this thing here is malfunctioning badly. I don't know why. Because I wanted to write one other thing before. I hear what I can mention it next week. I wanted to talk about the internal bit, but the computer is giving me a bit of a problem. It's not behaving properly at all. I don't know what happened with the mouse. All right, so I have the book to post in the group. Book with wiring and diagrams and so forth. So I'm going to post that in the group now. And we think we can be here first assignment. So okay, so here is how we are going to progress with this thing. You're going to get an online multiple choice test. maybe 20 or 30 questions depending on so an online multiple choice test. At some point near the end of the term, we're going to have to come in to do some practical classes to learn to wire up the PLC. So you wire up the PLC and write the program, and that is one. And then 2 written code assignments where we ask you to write the code for a particular problem, and that will be your four things that we're going to be using. Are you hearing me?
Yes, sir.
Hello?
Yes,
Yes,
sir.
sir.
Hearing.
Yes, sir.
Hello. So those are the 4 things you're going to get. So I'm going to post the first assignment either today or tomorrow or by Monday, and I'm going to put out the book and the book. I put up the 2 assignments. Like I said, towards the end of the term, later down, we're going to ask to come in for 2 or 3 sessions, learn how to wire thing, and what test we ask to write a program, wire up the circuit. Usually that is not a problem. So we take it from there. All right. Because of this thing, I give me some trouble that I'm going to stop it for this evening. All right.
All right,
Like I
sir.
said, the computer completely freeze up, so I'm going to log off now.
Sir.
Uh-huh.
And Cindy,
Yeah.
what?
I'm hearing you.
I'd send you a WhatsApp message. I'll talk to you further on an idea or a thought that I have in regards to it.
All right.
All right.
Take up the phone. I don't know. Some people must inside of the room. Take up the phone and just drop on the battery just to say, all right, let me see. The phone just dropped.
Well, I'm going to drink some gin.
All right. So we're going to look up. He said computer entirely because, like I said, nothing. It looked like it's sick too. All right.
Okay,
So,
sir. Hope you get the question.
all right. All right. Thanks.
All right, sir.